All right, here's our bell work. X plus 3 equals negative 19, and this one's pretty nice actually because it's one stepper. So one principle of equality should do it on this one. We really just need to get rid of that plus 3 right there and drop the x. So to do that, we're going to subtract 3 there. But if you do it to one side, you got to do the other side. So that's going to zero that out just like we want. And negative 19 minus 3 is negative 22. Okay? And then, of course, we could check. You could say, well, negative 22 plus 3, does that equal negative 19? Put that in the calculator, and it will tell you that it is true. So that is the solution to this equation. All right, looks like we got a couple objectives today. First one here, I can simplify an equation with distribution and combining like terms if it needs to be. And I can solve an equation that requires many principles of equality. So take a minute and copy these two down, then we'll start our lesson. Now the good news on this first objective is that we've already done some combining like terms. I think we've done some distribution as well. And I think we did that in 1.4 from the last unit. And then using principles of equality, again, sometimes you just need more than one or more than two at a time. So a quick review, what is the solution? Remember that the value of x, or whatever letter you're replacing with the number, needs to make the original equation a true statement, right? So if I remember right, we looked at something like x equals 10. If you saw this equation, you'd have to replace x there with, well, 10. And you'll keep in mind that while this one makes it true, there's an infinite number of other values that would make this false. Okay, so only one value is going to make this true. We got to find the one value that makes it true. And we'll be using the principles of equality. So while the first lesson we only used one at a time, just like we did on the bell work. And the second lesson we used sometimes two. Now we're going to be using sometimes even more than two at a time, okay? But in addition to that, maybe some combining like terms and distribution. So here's our first example, negative 7y plus 4 minus y equals negative 36. Now, when we see this negative 7 coefficient of y, some students would say, look at this y, it doesn't have a coefficient. It does. It's considered not just a phantom 1 right there, but a negative 1. Because remember, it's going to take the operation to its left as its sign. Yeah, and these are like terms, so we can combine them. So this would be, and some people even like to put the line right there, just so they know they're only doing this to one side at a time. But how many y's would this be when we combine them? Because you got negative 7 of the y's, and then another negative 1y, that'd be negative 8 y's right there. We'll still drop this plus 4, and we'll clean this up a little bit, make this equal to negative 36. Now, I'm not seeing anything to combine on the right side, because there's only one number, but do be prepared not only on the homework, but in the lesson today, we're going to see more stuff to do on the right side as well, okay? But now what we've done, just by combining these two like terms, right? We had 4 terms, now we have 3 terms, which really makes this now a 2-step equation. So I should be able to finish this off with just 2 principles of equality. So I'll start with getting rid of that plus 4 so we can isolate the y's. And since it's plus 4, I will have to subtract 4 from both sides. Okay, so I'll bring my equal sign down. That will zero those out. I'll drop my negative 8y. And negative 36 minus 4 is negative 40. And then divide both sides by negative 8 to make that coefficient of y a phantom 1 right there, which leaves me with y equals negative 40 divided by negative 8. Just put that in the calculator, and you can be done with that. It's going to give you 5, okay? Now, the final question here, is 5 the solution to this equation? Well, that's where we need to go into the original equation, which is negative 7y plus 4 minus, I'll just put minus y. You can put minus 1y if you'd like, but equals negative 36, right? But all the y's that I see in this equation, I'm going to replace with the value of y that we think would make it true, which right now is 5. So this y becomes a 5, and this y becomes a 5. Now, I don't know if this is true or not yet, but we're going to find out. In fact, I can plug this all into the calculator instead of using the order of operations right here. So, let's go to my calculator. Find it. There we go. So negative 7, that'd be times 5. plus 4 minus 5. And you can put those in parentheses if you need, but from this left side, I did get negative 36, which is what I should have expected to get, and this does equal negative 36. That's a true statement. And since it is true, now I can go back to the solution that we had found, y equals 5, and box it in with a lot of confidence here, okay? Because we just proved here at the bottom that it is actually the solution. So here's an equation. And again, we look at this problem right here, and there's, what is there, 4 terms right here, right? So the first thing we'd want to do is see if there's any terms that we can combine, right? Because they're like terms. And the like terms that I see is the negative 18 and the negative 2. Of course, that reads negative 18 minus 2. It's the same thing. But we need to get the same answer either way. So negative 18 minus 2. Just put that in the calculator. That would give you negative 20. And this will equal the right side of the equation still. So it still equals x minus 5. And again, we had 4 terms to start out with. Just by combining like terms, we narrowed it down to 3 terms. And now, after we use the next principle of equality here to isolate the x, we should have 2 terms. So that means for me, I don't want that minus 5 with the x. I would like to just be able to drop the x as is. So how do I get rid of that negative 5? Add 5. But if you do it to one side, make sure you do it to the other side as well to zero that out. Negative 20 plus 5 is negative 15. So I get negative 15 equals x. Now the coefficient of x right now is already a phantom 1, so that should be complete. Okay. Now we've already done negative 18 minus 2. This is to check to make sure that negative 15 is the one and only solution here. Negative 18 minus 2 is negative 20, but replace x here with negative 15 and minus 5 on the calculator. Negative 15 minus 5. Enter, and you get negative 20, just like we did here in red. Okay. So the right side shows that if you replace x with negative 15, you get negative 20. The left side shows when you combine these two, you get negative 20, which is a true statement. Therefore, negative 15 is the actual solution to this equation. Here's our next equation. Negative 4, parentheses 8x plus 9, close parentheses, equals negative 36. Now you guys try this one out. Take 1 minute, then we'll go over it, okay? So the first thing I see on this one is some distribution of that negative 4. Now some of you know a little trick where you can use the principle of equality right here to get rid of the negative 4. And if you know that trick, feel free to do it. But I'm going to stick with distribution right here because I don't think a lot of people would see that little trick right there. But this is all multiplication. Distribution is multiplication. So the first thing I see, my first distribution would be to distribute the negative 4 into the 8 x's right there, okay? So how many x's would that be? Negative 4 groups of 8 x's would be negative 32 x's. And then negative 4 times 9, here the second part, that's going to give us negative 36, okay? So I'll show the work there. We did negative 4 times, and that's positive 9 because of the plus 9, okay? Well, this will equal this negative 36, okay? Now, negative 4 times 9 was this red negative 36. I wrote this as a minus sign because, remember, since it's negative, we can just show this as minus, okay? Makes it a little bit simpler. And now we have the 3 terms, which means that really we're looking at a 2-step equation. We should be able to do this in 2 steps. So I don't want that minus 36 with the negative 32 x's. I would like to be able to just drop this negative 32 x's right here and zero out that negative 36. So I got to zero that out by adding 36. Okay, now that will be 0. And I'm making this a phantom 0. But remember, whatever you do to one side, you got to do to the other side. So I'm going to add 36 to the right side as well. And what happens here is negative 36 plus 36 is 0, just like it was on the left, okay? Now, I don't want this to be a phantom 0. Otherwise, if I take it away, if I take it away, where did that go? There we go. This is a nice one right here. And we have some like terms to combine, not only on one side, but on both sides. Now, So the first thing I see here is the negative 36 minus negative 6. Now some of you use keep change on this, but the calculator would have done that for you even with you if you did the minus negative stuff, okay? In any case, whatever you put into your calculator, you need to get 3 right there. Because negative 3 either plus positive 6 or negative 3 minus negative 6 is actually positive 3. So those were 2 like terms that I could combine. They're just regular numbers. Then on the right side, there's these x terms that I can combine, right? So how many x's would that be? 19x's minus 17x's is 2x's. And then the plus 9 I'll just drop because there was no other like terms to combine with that plus 9. So there we go. We had 5 terms, which we have now narrowed down to 3 terms. And yeah, that means we got a 2-step equation here. So that plus 9, I don't want it there. I would like the 2 x's to be by themselves. So I'm going to have to subtract 9 from both sides to zero that out. And then 3 minus 9 is negative 6, which equals, here, now, we'll drop the 2x. So from 5 terms to 3 terms, now 2 terms, which means that we should be on the final step here, the final principle of equality. Just divide both sides by the coefficient 2. And that gives us x equals negative 6 divided by 2 is negative 3. You can put your calculator in there just to make sure. Now we already did the calculator to make sure that this left side was actually positive 3. But now I'm going to go in and replace these x's with negative 3. And then I will check to see if this will be true. And again, that's something I can do in the calculator. It's kind of long to do with order of operations. So we got 19 times negative 3 minus 17 times negative 3. You can put those negatives in parentheses. That would probably be the best thing to do until we get more used to it. And then plus 9. Now when I push enter, I should expect to see a 3 because I know on the left side we expected to see 3 right there. And yep, I push enter, I see it does equal 3, which means that x equals negative 3 is the one true solution to this equation. Now I'll emphasize this again. There's an infinite number of values you could replace x with right here and make this a false statement. There's the only one that's going to make this true. Here's another one, and it's kind of like that last one we just did, but I guess the sides of the x's switch. So it shouldn't matter which side the x's are on, hopefully by now. We just need to solve for what the x value would be to make this a true statement. So we got 5 terms again. We're going to narrow this down into 3 terms because there's 2 sets of like terms that I can combine. So I got the negative 7x's and the positive 5x's, which would result in negative 2x's. I'll drop this plus 3, and you'll have to be careful because some students in the past, they've taken this plus 3 and combined it with negative 5 and minus 4 right there. But you have to use principles of equality to combine those. You've got to zero this out, right? Which we will do. And then negative 5 minus 4, put that in the calculator, you'll get negative 9. And if you want to use keep change, again, it's not going to make a difference. You should still get negative 9. But now I got to zero out that plus 3, which I will do. I want that plus 3 with my negative 2x's, so subtract 3, not just from one side, but both sides to zero that out, which it does. I'll drop my negative 2x's, which now equal negative 9 minus 3, which is negative 12. And the final step here is to make the coefficient of x a positive 1, not a negative 2. So I'll have to divide both sides by negative 2 to make that a phantom 1. So now x equals negative 12 divided by negative 2, which would be positive 6. Now, as usual, I'm going to go back and check. So I'm going to replace these x's with a positive 6. And my question mark over the equal sign means that I'm checking to see if this is true. Now, I've already done the right side with the calculator. Negative 5 minus 4, we got negative 9. So when I replace these x's with 6's, I should get a true statement right there, okay? So negative 7 times 6 plus 5 times 6 plus 3 equals negative 9. Yep, so that's true. Now I know that x equals 6 is the solution to this equation. So on this one, we got some distribution, and then it looks like we'll still have some combining like terms. Be careful not to combine these 2 terms, which are like terms, but they're outside the order of operations. You have to do this multiplication with distribution before you do the subtraction, okay? So make sure you don't do that first. And you definitely cannot combine the negative 11x's and the positive 4 because they're not like terms either. What I want to do is I want to distribute this negative 7 into the parentheses here, okay? So that means between these two terms, I'm going to take the negative 7 and multiply it by the negative 11x's, but also take the negative 7 and multiply it by, that's positive 4 because of the plus sign right there. So what do we get on this? Well, negative 7 times negative 11x's. How many x's would that be? It'd be 77 x's. It's a lot of x's. That's okay. And then over here, that's negative 7 times positive 4, which would result in negative 28. So we're gonna, instead of writing that as plus negative 28, I just make that minus 28, and then we're good to go there. So the rest of this equation, negative 110, equals 77 x's minus 28 minus 5. So that's the distribution portion of this equation. Now, I'm looking for any like terms to combine, and I see the negative 28 and the negative 5, which when combined give us negative 33. So now I got negative 110 equals 77 x's minus 33. So yeah, now we're down to 3 terms. There's no distribution, no other combining of like terms. So I just want to isolate the x's by zeroing out that 33. So add 33. But to both sides, so negative 110 plus 33, just using the calculator, it shows negative 77, which now equals, here I'll drop my 77 x's, and then the negative 33 plus 33 became 0. So we're down to one final step, one final principle of equality, to divide both sides by the coefficient, which is a positive 77. Which tells me that x, that's a phantom 1 now. Phantom 1x equals negative 1. Just put that in the calculator if you need to. Now, what will happen then if I replace this x with negative 1? Will it make this a true statement? Well, that's what we want to find out, okay? So here's my question mark above the equal sign, because I don't know if it's true. I can type that in exactly like I see it. So negative 7, open parentheses, negative 11. Open parentheses, negative 1, close that parentheses to show the multiplication, and then plus 4, close parentheses, and then minus 5. And again, when I push enter on the calculator, I should expect to see negative 110. If I see something else, then I will know that I made a mistake somewhere in the work there. But I push enter, and I see negative 110, which means that x equals negative 1 is the only true solution for this particular equation. Now, just to be clear, this is where 8th grade starts to differ from what you saw in 7th grade. In 7th grade, you usually stop at 2-step equations, but now we see multi-step equations, which include distribution and combining like terms, and then some other principles of equality, okay? And keep in mind that the next lesson will include even more distribution and combining like terms, and possibly even more principle of equality, because we're just going to be solving problems that get bigger at this point, but the process is the same. Always distribute if you need to, then combine like terms if you need to, then isolate your x's, and then finally divide both sides by the coefficient. And those last 2 steps would be using principles of equality.